if I go back to hey friends, welcome back. Now let's do a final Power BI Python project. And this is a data science project, so we do a little bit of machine learning, but we don't dive into that too deep because this is mainly focusing on Power BI discourse, not on data science. However, I think it is a good use case and you see exactly what happens when you apply code in Power BI. So here I already opened my Jupyter notebook and up there's the code we already talked about. This here, actually we start with the data science project. The code is already written, so you don't have to see me writing all this code, but this is of course available for you in a resource section. And you could also provide your own code and write your own code if you want. At the beginning, we import the necessary libraries here. So I'm using the OS module because here I need to change the directory in order to read the data, which I want to use, which is this customer churn in here. And I do a few other imports like Seaborn Pandas and so on. A few of them you don't need actually, or we don't need in Power BI then because for instance here the pipeline, I tried that. You can use this if you want, depending on your data science skills of course, but pipeline could help you to create or package everything you want to do considering the pre-processing aspect. Also you can try out compute class weight for imbalance classes, you can use SMOD. And so on, but just in case you don't know what I'm talking about, it's not that important. Okay, this is more data science aspect as I said before. And then you can use different kinds of machine learning algorithms. In this case, we stick to the scikit-learn library, which is really powerful and quite easy to use. Also import XGBoost here, which is the classifier I'm going to use. So the first thing you might notice already is so far in Power BI, we have our Power BI Python environment, and within this environment, there is no package scikit-learn and there is no package XGBoost. So when you want to use those packages, you know that you need to go to the Anaconda prompt and install those packages. Now I've already done this up front, but you see that all you need to do is simply type in pip install and then xgboost, you can run this and you see it's already satisfied for me, but you can install it and then it should download the file and install it for you. And the same is true for scikit-learn. So simply pip install sklearn. And if you're on this command, then this should also download all the necessary packages and install it in the environment. So again, make sure that you are in the Power BI for Python environment or whatever kind of name you gave your environment to install it in the right environment. So Power BI is able to use those packages later on as well. Now in this project, what we did was we load the data. Here we have a preview of what the data looks like. So it mainly contains names of customers, a few of their attributes, like age, total purchase, whether they had an account manager or not, the amount of years there have been, our customers, number of sites and so on. And the final thing we'd like to predict is whether a customer churn or not. This final column in here, which is a 1 or 0. So it's already labeled encoded. If it would not be, then you can apply label encode for instance to label encode is to basically make the column numeric. But that's already done here. As I said, it's a simple data set. Then here I'd use the Seaborn package, the heat map to plot the correlations for the numerical features to see whether there are specific correlations between them. Now there are only a few, numerical figures here. So it's just more interesting in whether is there any relationship or not. We can't plot it. You can also plot it in Power BI by the way, right? Using this command as an s.heatmap. And then you need to put in the data, the correlation of the data frame. But remember that's important that in Power BI, the data frame is not df. It's an abbreviation I'm going to use here, but in Power BI, I would refer to dataset by default. So here you can see I named this dataset DF, which is my common abbreviation for pandas. Data frames. But then what happens is we select the specific D types here for the columns. So when we specify X as select D types include number, that means we basically get rid of all the columns up there, which are not numeric, and only code would keep the numeric columns. With the y.equals x.pop, we simply say that from the X we have selected here, one column we want to remove. And this should be stored in Y, which will be our target column. So the X is referring to the features we have. Y will be the target column. And then we use a train test split here from also a scale, which allows us to split our data in training data and testing data, because by default, what you want is you want to train your machine learning algorithm or your neural network, whatever you can use on the training data set, and then you want to evaluate on the test data set. The test data set is then considered as a data set, which the algorithm has not seen before, like in the real world, right? And we specify a random state, which means we should get reproduced, reproducible results. And we stratify the Y to make sure that we have the same, ratio of Ys in the training data set as well in the test data set, considering the original ratio. Then we use a scaler in here, which is best practice. If you have an article, features and you want to scale those in most of the cases. There are few algorithms like, for instance, decision tree where it actually doesn't matter too much, but other algorithms are highly, dependable or highly dependent on scaling the features. And we also transform it. And we do the scaling on the training data set here. And then we apply it on the training data set with transform as well as on the test data set. So the test data set will be scaled based on a training data set, not on the test data set. Okay. That's important. And then this is quite easy. We instantiate our classifier and then we fit the classifier on the training data, on the scaled training data. And then we score here the accuracy. And in my case, I got an accuracy score of 90% here for the data set. And here I simply put it in the data frame, but that's not that important for us now. What we want to do here as well is we predict them based on the test data set. Remember, this is the unseen data set. And then we store this in the results. We just reset the index because resetting the index allows us then to join the predictions we made in this one here. And then finally we merged the data here, so from the results we have with DF company. Simply to add this company column back in here, we said left on the index. Here we have an index inside and right index is equals to. That's referring to the original data frame here, which has a company name and also an index, which is referring to 748, which means that customer 748 will be joined from the original data set and his name was Lopez Nelson, in this case, or the company name. So that's basically what we do. So if you have questions regarding to this, feel free to ask in the comment section. I just want to keep this rather short because, as I said, it's not a data science course. And in case you are not interested in this topic, then you can skip the lecture together, if you want. But if you want to see what happens actually in Power BI is here, I shrink the code pretty much, and as I said, this is what you can download from the source section. If you want to try this, you can copy this and then you need to open up a complete new Power BI file. There's an empty file here. And the first thing we need to do, of course, before we can run any Python script, or actually, we have two options, right? We could go to get data and run a Python script in here, or which I would like to prefer here now is go to Excel, or go to tax CSV and import the data first and then run the script in the query editor. So I go to tax CSV, I take this option and then I choose my customer churn CSV. You find this in the resource section, you can have a look at it. You click on open and import the data just normally in Power BI. So we wait until now we get appears. There it is. And we can see here we got the name, the age, total purchase, and so on. So exactly the data frame which we all sorts have seen in the original file, right? In the 2-bit notebook. Now I go to transform data, click this option and then the editor opens in here and here. We can see the data. But what we want to do now is we go to transform and then we run a Python script. So you click the strong option here and here we go. And then we simply paste this inside and you will notice that here, if I go back to my code, I already change here the df to data set, okay, as I refer to data set here, which is exactly the data set we have here imported inside, right? Because by default, if you scroll to the top, you can see here, data set holds the input data for the script. And here you probably also see why it makes sense and what I would recommend if you write Python code, then I would always write it, or at least right now, I would always write it in my editor of choice and not directly in Power BI. Because in Power BI, you have no intelligence and the code looks simply like that, like plain text. So it's easier actually to write your Python code first in the editor of your choice and then you copy paste it inside and run the script. So editors, which I could recommend is for instance, Spider you could use Chip at a notebook or also Visual Studio Code, which is also a good one and I've used in the past, but there are various other out there as well. It's up to you what you want. But you create the code, then you can paste it inside. And if you run this, let me click on run, click OK. Then the Python script is run. We get this privacy issue here again, you can click continue and simply ignore the privacy levels, you click on save. Then you just wait a little bit until the data gets loaded. And important now, what you see is you see various tables in here. And if you want to have a preview of the table, simply click not on the table directly, this would expand the table, click right on the white space here, click inside. And then you see a preview of the data. And this is important to know that within your Python code, if I go back to my Python code here, you can click here on this little wheel and then you can modify it anytime if you want. But what happens here is that each data frame, and this only refers to data frame, not to variables. So if you create something like, for instance, the y here, the y equals x.pop, this is not a data frame anymore. This is why the y variable or the result of the y variable is not visible in here. What's visible here are only the pandas data frames you create in your code. For instance, when we say x equals data set to select the types include numeric here. This means that we create a subset of our original data frame, which contains only the numerical columns. And this is why x is a data frame and x therefore is showing up here. So if you want to create any kind of data or want to save any kind of data and want to have this as a table in Power BI, make sure you create a pandas data frame for that with in your code, because then it's visible in here. OK. So again, I click on, OK, I haven't changed anything. And then I can tick on my final. That's actually what I want. I can click this option and just wait. And there is my final data frame. And this is actually the table which I will choose. And if that's the fact, then I can simply click on this table. And as soon as I click on this table, then all the other tables get removed and I only keep this specific table in here. Now what if you create various data frames within your code and you want to keep several of them, not only one table? Because you don't want to combine all of them, right? They might have different kinds of information and you don't want to stack them. You only want to have specific tables. Then what you could do is you could right-click on the specific query you have. And there's a way to reference a query. There's also duplicate, but also reference. And I would go with reference because reference means that if your original query changes, you modify the code something inside here, then the reference would also modify the code. Because it's only referencing the original one. If you duplicate the query, then those two queries will not be linked anymore. Okay, that's a difference. But if I would say I'd like to have two tables from here and they are separate, I don't want to merge them in any way. Simply go to reference here. Then you have a second customer churn with all the tables, and then you could, for instance, take any other kind of table in here. And then it works with the default behavior in Power BI. You have simply two tables with different kind of information. But the second one is a reference of the first one. Okay, so just in case that's of interest to you. For me, that's not. So that is why I right-click here and say delete again, because I don't need it. But I just wanted to mention that here. What I want is I want my final results. So I click on this table, final, and then I just expand the table, and here is the data. So we can see index, age, total purchases, and so on, and also the prediction made by our model and then the company name. And then you can do few additional transformations if you want, or you say we're good to go and say I go to home, go to close and apply, take this option, and then we wait until the data gets loaded into the Power BI report. And here we go. Just seconds until data is available. And there it is, customer loaded, and the tables available for us. And now we can do any kind of visualization. So we could go say, I'd like to see let's say the total purchases. And I also like to see maybe the age, take this option here as well. And I don't want to see a bar, instead what I want to see a scatter chart as an example. I can make this bigger, and then I can see here only one dot because currently the data is aggregated. But let's say I'd like to see this for each customer company. So I can drag my custom company into the details section here. And I have simply all those insights. And then I could go with my prediction. So remember which customers will churn and use the prediction and drag this, for instance, in the legend. And if I do that, then I can see the data points here and the prediction 0 and 1. And I can see all my customers, and also highlighted in this get a plot which of those customers might churn predicted by our model. Okay. So that's it. That's how that works. Actually, that was a case study for applying machine learning. And as I said, you can make this as complex as you want. You can dive deeper into Skype, learn, you can train, you can tune your hyperparameters using grid search or random search. You can apply neural networks. You can use TensorFlow or PyTorch if you want, and also do those inside or use those models inside Power BI. Just make sure that all the libraries you use, you need to import or install them first here in your specific environment. But that's it actually for this video. So hopefully that little case study was helpful to you. And thanks a lot for watching. As always, wish you all the best and hopefully see you in the next video. Until then, best guys.